Assalamualaikum warahmatullahi wabarakatuh. I hope you are healthy, in good condition. Okay, so in this lesson, we will focus on pressure measurement by a manometer. So last week, we have learned on the definition of pressure, how it's related with force and area. Okay, and we also have looked at head, the calculation for head. P equals to rho GH, and the H is referred to head. And here, the relationship between pressure and head is used to measure pressure with a manometer. So it is also known as a liquid gauge. In this course, you will learn four types of manometer. So first one is piezometer tube manometer, U-tube manometer, inverted U-tube manometer, and the last one is inclined manometer. So we will look at each of these one by one. So for the first one is the piezometer tube manometer. So the image is like this. You only have a small, you have a tube open at top and attached to a vessel that contain liquid at a pressure, and that pressure must be higher than atmospheric. Okay, this is the example of a piezometer tube. So as the tube is open to atmosphere, the pressure measured is relative to atmospheric, so it is gauge pressure. So you have from previous diagram, we have something like this, the vessel. Okay, you need to, sorry for my bad drawing, but you need to know that the bottom one is a sphere and is attached to a tube. Okay, and the center of the column is, we call it B. Okay, and A is the point where your tube attached to that sphere, the vessel. Okay, so pressure at A is equal to pressure due to column liquid above A. So it is, say your liquid is up until this. So pressure at A is rho GH1. Rho is the density of the fluid inside the piezometer tube, while the pressure at B is pressure due to column liquid above B. B is the center of your sphere, your vessel. So PB is equal to rho GH2. Alright. Okay, let's check. Okay. However, there are some disadvantage of piezometer. First, it cannot measure suction pressure, which is lower than atmospheric pressure. The piezometer is designed only for us to measure pressure that is more than atmospheric pressure. Second one, okay, the pressure measured is limited by available column height, which means that the pressure measured must be relatively small so that the height of the column is reasonable. So if your pressure is high or too much, you won't have a reasonable height H1. It cannot be like a small sphere attached to a very long tube. It's not stable, right? So it's not. So your pressure measurement is limited by available column height. So it's only for a lower pressure measurement. And the third one is only deal with liquid, not gases. So because of that, we can opt for another type of manometer to suit with both liquid and gases. Okay, so here, this is one example that related with piezometer tube. Another name for piezometer tube is a pressure tube. Okay. The pressure tube is used to measure the pressure of oil. Mass density equal to 640 kg per meter cube in a pipeline. If the oil rises to a height of 1.2 above the center of the pipe, what is the gauge pressure in Newton per meter squared at that point? And given gravity as 9.81 meter per second squared. So you just use the rho GH, P equal to rho GH, and the height is given as 1.2. Okay, so this is PB. So your rho is 640 multiplied by gravity 9.81 multiplied by height 1.2. So your P is 7,534.08 Newton per meter squared. Okay, because this you will get the unit, you will get unit in kg per meter second squared. Okay, and this 1 Newton per meter squared is equal to 1 kg per meter second squared. Alright, so let's proceed for next example. What is the maximum gauge pressure of water that can be measured by means of a piezometer tube 2 meter height? And what if the liquid has relative density of 8.5? What will be the maximum measurable gauge pressure? So first, let's look for water. P is equal to rho GH. So your rho for water, if it's not given in the question, so rho for water will always be 1000 kg per meter cube. Okay, 9.81 gravity. H is 2 meter. Okay, so same. You just plug in these numbers in your calculator. So you will get pressure as 1.19620 Newton per meter cube. Okay, so normally we will simplify this to convert this to kilo nanometer per cube. So you will get 19.62 kN per meter square. Alright, so then for the liquid, for the other one, given that relative density, so recall back, relative density is equal to your specific gravity, where the formula is Sg equal to rho of that fluid over rho of water. Okay, so in this case, you want to know the rho of liquid. It's 8.5 multiplied by 1000. Okay, don't forget the unit, kg per meter cube. So it is 8500 kg per meter cube. Okay, so now once you know your rho, your density, you can calculate for pressure. And same formula. Because we want to know the maximum measurable gauge pressure. So it must be to the center of your vessel, maximum H2. Okay, 9.81. And height is the same, 2 meter. So solve for this and you get pressure as 166,770 Newton per meter squared. So final answer is, okay, it would be nicer if you can convert to kilonewton, 166.77 per meters. Alright, so this is the answer for liquid and this one is for water. Okay, so in next video we will talk about the YouTube manometer. Alright, thank you.